Hello and welcome to another one of D's ADD videos. Today we're going to look at an example of calculating the rate law from experimental data. The student's audio has been turned off because she is shy. Please attempt this problem on your own if you can. Pause it and then look at the solution. Good luck.
Yes, ma'am. That's exactly right. And we're trying to find what X, Y are, and we're also trying to find out what K is. So, okay. Well, in the video, I mentioned that, if we want the first column reactant, we have to look at where the second column is constant. Okay. So in this reaction here, the ratio of the two concentrations, and we need to be making a ratio out of them. So here is the first column, and then the other reactant is the iodine. These are in molarity. So you see how on the last two columns, or last two rows, sorry, that's where we're constant. So you see how it's the 0.017 here. These two are constant molarities for the I column. So as a result, what we do is we make a ratio of the second and third experiment to try to find out what X is. In this case, A is going to be constant as these stay the same. You see how this 0.17 is the same in experiment 2 and in experiment 3? That's staying constant. It's remaining the same. Anytime it does that, I can go over to the other column, make a ratio of those two rates or concentrations, sorry. Let's do the bigger one over the smaller one. And it's going to be raised to the X. Why did I choose X? Because I'm equating the first column to A, second column to B. Okay? And then I set it equal to a ratio of their rates, which I did not write on this table. Let me write those down real quick. So the rate for each one of those experiments. So basically what we have here is a table depicting at these two concentrations, the experiment took this long. Okay, whenever A was 0.08 and B was 0.034. Whenever A was 0.08 and B was 0.017, the reaction took this long. You understand what this is saying? Sure. Whenever I have a reaction, you see the reaction at the top of the page, and I use the concentrations of 0.08 molar for the S2O8 and 0.034 molar for the iodide, the reaction will take, the initial reaction rate will be 2.2 times 10 to the negative 4 molar per second. Whenever the reactant concentrations are 0.08 and 0.017, the reaction rate will be 1.1 times 10 to the negative 4 molar per second. No, this is given to you. That's all that you see in your book right now is given. This table is all given. What we're trying to figure out is this. What does this look like? Now, I'm looking for K, X, and Y, and those. So at these two concentrations, that was the initial rate. These two concentrations, that was the initial rate. These two concentrations, the rate is 2.2, again, times 10 to the negative 4, okay? So what we did was we set a ratio of this and this, and I put an X up there because we're dealing with the first reactant and the exponent of the first reactant. And yeah, so I looked in, and when I'm finding X, I look in the B column for where it's constant. It was in 2 and 3, so I did a ratio of 2 and 3 from A. One more time. I'm looking for x, which is the exponent of the A column, the first column. So whenever I'm looking for the exponent of the first column, I go to the second column, look for where it's constant. Once I find where it's constant, I go back to the first column and I make a ratio of those two experiments where the second column was constant. So look at the first column in this case. Yeah, so we'll do that here in a second. So here we do a ratio of the...
And that's basically the rate law. So make sure you understand the concept. I went through it slow and repeated it a couple times. That way you can clearly understand what's going on. All you got to do now is practice a few of them on your own, okay? And the key to all this stuff, whatever you're taking, is practice. The more you do, the easier it becomes, the less surprise there is, the less anxiety. I hope I've eliminated any doubts you might have. Thank you and have a nice day.